Hello everyone, welcome back to our channel. So today we'll be discussing what the Pythagoras theorem is. This is one of the very important theorems of mathematics, and this theorem is related to right angle triangles. So whenever you see a right angle triangle when you're doing mathematics, most probably you'll be using the Pythagoras theorem. Obviously, this is the main root or base of all of trigonometry. But in case of trigonometry, this is like ABCD, like you build up the base of the entire trigonometry on the Pythagoras theorem. But it's not just trigonometry. So we use Pythagoras theorem sometimes when we need to find the area of triangles. We use Pythagoras theorem in height and distance. We use Pythagoras theorem in cones. So whenever we can make a right angle triangle anywhere in mathematics, we will most probably use the Pythagoras theorem. So what is the Pythagoras theorem? Pythagoras theorem is the theorem on right angle triangles. So first let's make a right angle triangle. So first let's make our first side of our triangle, and let's make another side so that they are 90 degrees, okay, so that they are right angle. And let's join this side with this side. And there we have it. This is our right angled triangle, okay? Let's name this triangle A, B, C. So we have our right angled triangle now. What the Pythagoras theorem tells us is that, let's say this side of our triangle is P, this side is Q, and this side is R. Then, according to Pythagoras theorem, the square of this longest side of the triangle, right, which is our P, is equal to the sum of square of these two other sides of the triangle. So, what that means is the square of this P is equal to Q square plus R square. The square of this side is equal to the sum of the square of this and the square of that. And no matter how many right angle triangles you make, it's always going to be correct, okay? The square of this longest side is always going to be the sum of the square of this side and that side. And that's it. That's the Pythagoras theorem. But what Pythagoras did is he gave these three sides of the triangle their own names, okay? So he called this longest side the hypotenuse. Hypotenuse. And he called this side perpendicular. He called this side the base. Now, if we write our hypotenuse as H, okay, and this perpendicular as P, and this base as B, then our Pythagoras theorem is going to look something like this. H square is equal to P square plus B square. So again, the square of this longest side is equal to the sum of square of this, P square, and the square of this, okay? And usually when you see the Pythagoras theorem, it's like this, right? H square is equal to P square plus B square. But it's just a notation, okay? We can write it as P square equals to Q square plus R square, or maybe A square equals to B square plus C square. It's just that the square of this longest side is equal to the sum of the square of the other two sides. Now, regarding the perpendicular and the base, okay, the hypotenuse is always the longest side, or you could say the side which is pointed by our right angle, okay? So that's our hypotenuse. In case of perpendicular and base, usually we can assume any of these sides as perpendicular and the other side as base, okay? So we could have assumed this BC side as perpendicular and this AB side as base. But when an angle is given in the question, okay, sometimes one of these angles is given, okay, either A or C, okay? So when an angle is given in the question, let's say the angle is given at our C, okay, this angle is given. It could be of any value, right? It could be 30 degrees, it could be 60 degrees, or it could be 45 degrees, right? So we are going to assume this angle as theta, okay? So this is some angle. So when this angle is given in the question, in those cases, we can't just assume any of the sides as perpendicular and base, okay? In those cases, the side opposite to this angle, okay, the angle given in the question is the perpendicular and the remaining side is the base. Or you could look at it this way. The side where there are two angles, okay, there is right angle and there is this theta angle in this side BC, right? That side would be our base and the remaining side would be our perpendicular, okay? But when this angle is not given, you could assume either one of these sides has perpendicular and base, okay? But the hypotenuse is never going to change. It's always opposite to this right angle and it's always the longest side of the triangle. Now that we know the terms hypotenuse, perpendicular, and base, we usually write the Pythagoras theorem as h square equals to b square plus b square. Now let's look at an example, okay? So first, let's make our right angle triangle. So we have our right angle triangle now. Let's name this right angle triangle P, Q, and R. And let's say when you measure this right angle triangle, you get this side as 3 centimeter, this side as 4 centimeter, and this side as 5 centimeter. Now, since this PR is our longest side, right, this is going to be our hypotenuse. This side, let's assume this as our perpendicular, and let's say this side is our base or B. Now, we know that the h square, right, hypotenuse square is 5 square, which is going to be 25. The P square, okay, the square of 3 is going to be 9. And the B square, the square of 4 is going to be 16. Now, according to Pythagoras theorem, when you add this P square and B square, we should get h square, right? We should get 25. Let's check. So if you add 9 and 16, right? 9 plus 16 is 25. So P square plus B square is really h square. See, that's the Pythagoras theorem. Now you might say, I just put in these numbers so that I can match this with the Pythagoras theorem. But you can try this at your home, okay? So you try to make a straight line, right? Make that 3 centimeters and then make another line, right? And make that 4 centimeters and connect these two lines, okay? This should be right angle. This side is always going to be 5 centimeter, okay? It's not that I made it up, okay? Try it at your home. Make a triangle, right angle triangle. Make this side 3, make this side 4. For this side, you don't need to measure, okay? Just join these 2 points, okay? This point and that point, and you will always end up getting 5 centimeter. Try that, okay? Or you could make another triangle. So you make one side, let's say 6 centimeter, and make another side 8 centimeter. This should be 90 degrees, okay? Because we need to make a right angle triangle. And then you don't measure this side, okay? You just connect these two lines, right? You're always going to get this side as 10 centimeter, okay? It's always going to be 10 centimeter. Now you might ask, how do I know this side is always going to be 10 centimeter? It's from the Pythagoras theorem. So we have that h square should be equal to p square plus b square, right? And we know this side is our h. So we can assume this as, again, our p and this as our b. So p square is going to be the square of 6, which is going to be 36. B square is going to be the square of 8, right? It's going to be 64. And when you add those two together, you get 100, right? So you get h square is equal to 100. And to find h, just square root 100 and you get 10. So I knew this side is going to be 10 with the help of Pythagoras theorem. Now, if the Pythagoras theorem is wrong, it could be 11, it could be 9, it could be 15, right? But I'm 100% sure that the Pythagoras theorem is correct. So it's always going to be 10 centimeter. There might be some margin of error, right? It could be 9.9 or 10.01, right? That's a different thing, but it's always going to be almost 10, okay? If it's not 10, then the Pythagoras theorem is wrong, okay? You have proved the Pythagoras theorem wrong. And it's not going to happen, right? This is a very, very, very old theorem and it's 100% correct, okay? It has been proven mathematically that it's correct and it is correct. So it's always going to be 10. Now, what's the use of this theorem? Do you really need this theorem? Obviously, you need it, right? That's why we are learning the theorem. So I have actually showed you how we can use this theorem to solve mathematics, okay? Here, I found out that this side is 10 centimeter by using the Pythagoras theorem, right? So if you know the two sides of a right angle triangle, then you can find the third side with the help of Pythagoras theorem. So for example, let's look at another right angle triangle, okay? So again, we have our right angle triangle, right? Let's say, again, we know two sides of the triangle, right? Let's say this is 7 centimeter, and let's say this is 24 centimeter, okay? And we don't know this third side, okay? Now we are going to find the value of this third side by using the Pythagoras theorem. So this side is our h, this side is our p, and this side is our b, right? And we know from the Pythagoras theorem that h square is equal to p square plus b square. So we have our p is 7, right? So 7 square plus our b is 24. So it's going to be 24 square is equal to, so 7 square is 49 plus 24 square is 576 is equals to 625, right? So this is our h square. When you remove this square, it's going to be square root over here. So we have square root 625. This is going to be 25. And we have found our hypotenuse. So this side is 25 centimeter. See, we just found this third side with the help of Pythagoras theorem. Now you might wonder, can you also find P when like H and B are different? Obviously, we can find that, right? So if, let's say, this side is not 7, okay, then this side is not 25, and this side is not 24. Let's say this hypotenuse, okay, let's say we know this side, let's say it's 13 centimeter. And let's say this base is, let's say, 12 centimeter, okay? And then we need to find the perpendicular, right? How do we find this side? We know the other two sides, right? But we need to find the perpendicular. Again, we are going to use the Pythagoras theorem, okay? So how? So first we have h square is equal to p square plus b square. But for this problem, we need the perpendicular, right? So let's make the perpendicular alone, okay? When we move this b square to the left side, it's going to be h square minus b square, right? Because it's plus b square over there. When it comes to the left side, it's going to be minus b square is equal to p square. So we have our p square as h square minus b square. So now our h is 13, right? So 13 square is going to be 169 minus our b is 12, right? So 12 square is going to be 144. And this is going to be equal to 25. Now, again, we need to remove this square, right? When you remove that square, again, we have our square root, and square root of 25 is 5. So this side, our perpendicular is going to be 5 centimeter. Similarly, if you need it like b, let's say, okay, h and p are given, then you move this p to the left side, right? And it's going to be h square minus p square is equal to b square, right? And again, you can flip this and write this as p square equals to h square minus p square. And again, find the value of b by putting the values of h and p, okay? So we can find the third side of a triangle whenever the other two sides are given, if the triangle is a right angle triangle with the help of the Pythagoras theorem. Now, this might look, pretty easy and simple, but it's very, very important, okay? If you're learning math, you'll definitely use the Pythagoras theorem somewhere, okay? So it's very, very important. So a lot of students find this Pythagoras theorem very, very difficult because of one misunderstanding, okay? These h, p, and b are just letter symbols, okay? Which is used to denote this longest side and the other two sides, okay? This could be any other letters, okay? It could be A, B, C, it could be P, Q, R, and any other letters. So if you were to assume this side, right, the longest side as, let's say, L, and let's say this side as, let's say, H, and this side as our R, then the Pythagoras theorem is not like h square equals to L square plus R square, okay? This h is not the hypotenuse. The hypotenuse is this longest side, okay? And the Pythagoras theorem is L square. The longest side square is equal to the sum of the squares of the other two sides. So it's going to be h square plus R square. These letters h, p, and b are just symbols. The actual Pythagoras theorem is the square of this longest side of the triangle is equal to the sum of the square of this side and that side. The letters can always change, but the theorem is the square of the longest side is always equal to the sum of the square of other two sides. And that's our Pythagoras theorem. So if you enjoyed our video, please give us a thumbs up and subscribe to our channel for future maths videos. Thank you.